Welcome to Smarter Aviation Data Management, Lessons from Swedavia, Airports, and Sweco. Today, we have the pleasure of being joined by our two guest speakers from Sweco and Dean. I will pass things over to Johan to introduce himself.
Okay, thank you. Yes, my name is Johan Ludvigsson, and I'm, as it says there, GIS consultant at Sweco. Been working at Sweco for 25 years and roughly 20 years doing FME work.
Yeah, and well, obviously I work at Sweco as well, which is a consulting company, mainly architects, engineers, and I quote from the homepage, it says, architects, engineers, and other experts. So I guess we are, what do you think, Johan? Are we in the other experts category? I've been working with FME for like 25 years and a long time at Sweco as well. So long time FME nerd, tend to do more and more project management stuff, even though I would like to be in the details of FME.
Yeah.
Cool. Yeah, I would like to welcome myself. I'd like to welcome Johan and Ulf here. It's great to have them joining us on this. And yeah, I'm Dean Hintz. I guess I work for the other standards or open standards. I'm product manager for that at SAFE, as well as I head up the strategic solutions team. So we do all sorts of, I guess, other projects, skunkworks, kind of biz dev stuff.
Dean is in charge of a lot. I couldn't fit his whole job title onto this slide, so that's great. Awesome.
Right on.
Perfect. So before we dive in here, thanks to the three of you, I'll just give a quick overview of Livestorm. If you have any audio issues or any webcam issues, click that help button on the bottom left for 4 simple steps to take. And then you can also share your emoji reactions with us during the webinar. I've already seen some come through. Those are always fun to see. We do have a poll coming up shortly, so keep an eye on that polls tab. Chat, keep letting us know where you are tuning in from, leave any comments there. And then questions. So please do, we encourage you to ask any questions you might have during the webinar here. I know it is a more intermediate and beyond level for this webinar. So yeah, if you have any questions whatsoever as we go through today's use cases and demos, please don't hesitate to ask those. We will have a little bit of time dedicated at the end to answer those, and we might be able to get to some during the webinar in that panel as well. And if you'd like to download the slides, you can click that download button on the top right of the PDF. All right, so from here, I will pass things over to Dean, but before I do that, I will prompt our presenters to turn off their webcams just so we can save on some bandwidth here for the remainder.
Right. Yeah, so today I'm just going through the agenda here. Talk about aviation data management with FME and what are the challenges associated with AIXM and how can FME help us with those. And then Ulf and Johan will take us through a customer use case with Swedavia Airports that Sweco has been supporting for some time. And then we'll look at I have a quick demo to illustrate some new innovations that we've invested with development around AIXM, and then some summary and next steps.
Awesome.
So yeah, Elizabeth, why don't you take us away with the poll here, first one.
Perfect. Okay, so I've published that now under the polls tab. We'll have everyone head over there and we'll give everyone a moment to let us know. Have you worked with AIXM data before? So it'll be interesting to see kind of where everyone's levels or experience is at.
Yeah, it seems like an even split between not at all and you know, somewhat or regularly. So yeah.
Yeah, awesome. Thank you, everyone. That's good to know going into the webinar today.
So that's, yeah, it is good to know. I won't assume sort of in-depth technical knowledge, but we will try to have something for everyone, both the newer folks and experts. So yeah, we're going to look at how can we streamline our AIXM or aeronautical data processing, including things like reporting, ensuring accuracy, and ultimately meeting the aviation data standards, all without manual effort. So AIXM stands for Aeronautical Information Exchange Model, and its purpose is to provide a digital format for aeronautical information services. And AIS supports things like air traffic control, as well as just managing the airport and airspaces and flight routes and more broadly. And obviously, for safety reasons, high data quality is essential, but we need to do that in a cost-effective manner. And as a part of sort of the background, AIXM and AIS in general were a way of digitizing what were prior manual workflows. And so that process, you would think, oh, everything's fully automated and fully integrated, but it's amazing how, how much legacy stuff is still out there. And so ultimately, AIXM supports data collection, verification, distribution, and transformation of aeronautical data. But because of the increasing demands and complexity of aeronautical systems, given more people traveling, just busier air networks, and even added things like UAVs, there's more and more need to have interconnectivity between these systems. So how can FME help? We help with automating data delivery, merging, managing aeronautical data sets, supporting the update process, and making sure those updates comply with those strict regulatory standards. And then with FME Flow, we can provide REST APIs and also a platform for custom workflows. So what are the main challenges around AIXM? Well, clearly aeronautical systems are highly specialized, and they might be, like the bottom point, they might be very sophisticated internally, but difficult to connect with each other. So that's a really important issue there. The data integration piece can be difficult. There's still a lot of manual workflows that can be prone to errors and delays. And the underlying data model, as you'll come to appreciate with AIXM, is quite complex. And so there's not a lot of tools that make it easy to work with that complex data model and the underlying GML and XML. And obviously, yeah, those strict regulatory requirements, and there can be local variations, between FAA or Eurocontrol and different nation states. So yeah, there is a better way with FME. You can automate these complex aviation workflows, reduce your manual effort, and all with meeting the standards. In terms of the FME platform, so that's what we're building these workflows on. FME Form is your authoring environment with sort of like no-code authoring, where you can drag and drop your data sources and process steps. FME Flow is the platform where you can automate, whether on-prem or hosted, and provide services and APIs. And then FME Realize. In this context, you could actually visualize the airspaces in 3D. And more broadly, something I was reminded to say in our summary later on, I'll try to remind everyone, we're focusing a lot on AIXM today, but underlying that is the support that FME has for a very broad range of formats. And so one of the background use cases with this is sort of like airport digital twin or airspace digital twin. And in that context, often we bring in data, 3D data, CAD, BIM, and many other types of data, raster, point clouds. So yeah, FME has unrivaled format support, and we try to keep that up, stay ahead of the curve on that. So I'll hand it over to Ulf and Johan, who are going to talk about Swedavia.
Thank you, Dean. Okay, so let's start. Who are Swedavia then? Well, they are the state-owned company responsible for the 10 major airports in Sweden, 4 international and 6 regional airports. And they are responsible for managing both the aeronautical part and the customer business part of it as well. The task they were presented was that they had to provide their data, updated data, to Eurocontrol for the European Aeronautical Information Service database, the EAG. And were tasked to send this data through Luftfartsverket, the enterprise responsible for air traffic control, who in turn will send the data to the EAD. And this data could not be sent as their baseline data, if you're familiar with the AIXM temporality model, but as permdeltas. That was very important. So they decided to use FME for this because, one, they already had FME form and flow working within the company for other tasks. And they knew that we were already working for Swedavia by the time, and they knew that we had experience with the AIXM format. Yep. So there we go.
So we're going to have a quick look at some of the data here in FME. So we're not just showing slides, I think. So
something more interesting and live.
Hopefully. So let's have a quick, AIXM, if we look at that in a text editor, it's a lot of XML. So many of you are probably familiar with that. So, but just to show here how you can access it in FME, this is one way. I drag and drop it in FME form. And as Dean mentioned, it's a fairly complex model in here. So you can see all of these. Yeah, what's the correct terminology there, Johan? Is it features or features and objects according to the model?
Yeah, we call them feature classes.
Feature classes, yeah. Anyway, we filter out all the time slices here to be able to view them. And you can see there are quite a few of them that could be in the data. And we look at them here quickly. And as I learned, time slices have all the fun geometries in most cases. So another way of looking at the data, if we drag and drop, is instead of filtering out based on a specific kind of object or type like that, I do a single merge there, which means that we basically read the entire file. But here I do some old trade of the tricks where I filter specific geometries. So here I basically say I want to see all the point, line, and area geometries in that AIXM file, which is the file that you will show parts of how we created Johan there. So if we run it like this, it's showing the same data, but it only shows the things that have geometries in here.
Yeah.
Yeah.
And the reason why there are so few geometries is the reason that Swedavia are joining us today and helping with the presentation. They are hard at work adding data to their database.
Yeah, to get more. But there is a lot of attribute work in getting all of that stuff correct, which can be quite hard. So, but as you see, FME can see all the kind of details, all the specific attributes and so on in here. So now zooming into Gothenburg, looking at that here. But yeah, you will show more how we created this file later on here. But just another example here, this is from Eurocontrol. They have some sample data on their website. It's some old demo data or sample data from, I think it's South America. Just to show here, if we read this, that there can be all kinds of different geometries. We have airspaces, different, you have departure leg, time slices, arrival legs, the nav aids, and so on in here. So that was a quick tip, filtering on geometries. Now, this is also a short demo here, turning this into KML. So we read the same sample data here. We have to handle some units and unit measurements to get that correctly, because it can be in many ways in the AIXM file. And we do some KML styling and we write it to KML. So it was fun to fire up Google Earth again to show this. I haven't used that in a long time, but here we see, for instance, some vertical structure in here that we have made to 3D. And also, as you noticed in Google Earth here, there were no 3D buildings here. So we added this in this demo that we fetch the Bing building footprints online and kind of put them in the KML file to make it a bit more enjoyable to watch. And also, we have the final leg and we show the airspace here. So this is a quick intro if you haven't seen the format before and what you can do with it.
Yeah, and if I could just add, you did filter on a lot of those time slices to show just the geometry features, but in order to, and that's a great way for visualization.
Yeah.
But when you're writing this in order to comply with the data model, it's important to understand the nested nature of the object model. So for example, a runway time slice has a parent object, which is the runway itself. And so we have to, that's a bit of a trick with this format. You have to maintain all those references and relationships in order to be a valid data set.
Oh, you're absolutely right about that. That's one of the big tricks.
Yeah. And the slightly counterintuitive fact that a runway doesn't have a geometry. It's built up with geometries from another feature class, which is the runway element.
Right.
Yep. Okay. Shall we continue then? So the setup for Swedavia was they had a customized web. They built a customized web app to trigger the AIXM exports. And they filter that on airport, temporality, valid date, and the actual AIXM feature types if they want to export everything or just parts of it. And then we used the REST API of FME to trigger jobs that deliver zip files containing all the data they requested and also customized log files. So that's the tool for sending their data to Luftfartsverket and then onto Eurocontrol. But they can also run the export directly from FME web interface for testing data quality and stuff like that.
Okay. Would you agree on that, Joe? On that, as Dean mentioned in the beginning, this is one of the major benefits with using FME Flow and Form. It's quite easy to integrate.
Yeah. I think so. I think this forum can agree with that.
Yeah, I was just curious, Johan. So I forgot to ask you this earlier. When you're automating that with the REST API, is FME posting that to the agency itself? Do they have a portal you can post to, or are you uploading it to an FTP file? FTP endpoint?
They decided that they didn't want the FME Flow to do that itself, so the FME job just creates the package and puts it where the Trust app then can pick it up and send and package it further and send it to Luftfartsverket. That was the architectural design, what they decided to do.
Okay, cool.
But it could have been, I mean, potentially it could have been FME Flow directly, as you say.
Yeah.
Yep. Okay, some choices made initially. The AIXM writer has kind of two different modes of working. Would you say that, Dean?
Yeah, there's more than one way you can use it for sure.
Yeah, and we decided to use the embedded object as geometries because we were more comfortable with that.
The alternative it being the linked geometries, is that what you're referring to?
Yeah, that's what it's called. I'm not quite sure, but that could be what it's called in the writer. It's a setting in the writer. Yeah. We weren't allowed to read directly from the SDE database that Swedavia has, so we had to use WFS as a data source, and we'll come back to that in the end. One master workspace submitting jobs with way to complete. We decided on way to complete for the first version to be absolute certain we have control of the flow. And also we decided to use mapping attributes with the attribute manager instead of schema mappers or anything like that. And we decided that because we thought it would be easier for Swedavia to maintain afterwards. Okay. So we built, in the end, we built 56 AIXM workspaces, one for each main class in the database. And of course, there are more than 56 main feature classes in AIXM. We built a template workspace identifying all the typical parts of the AIXM flow. And we also created a set of linked custom transformers for common combination of transformers that were easy. And then building of the actual workspaces was simply copying bookmarks, connecting them, configuring, and then do the attribute mapping in all the attribute managers. And we had created a very strict naming convention for everything. Transformers and weren't allowed to be called whatever. We needed to name them properly, because then we could auto-document it by using the workspace reader, which was quite fun to create.
Yeah. It's like FME reading FME.
It's FME reading FME, right?
Yeah.
Thank you.
If I can fill in there, go on. And I mean, having 56 workspaces from a maintenance point of view, that could be kind of scary, I think. But this method turned out quite well, didn't it?
Yeah, it did, and that's because we created these. That's actually the next slide, so we can do this. So this is a picture of one of the 56 workspaces, and here you can see that I was working with these predefined bookmarks from the template. On the left side, we have reading data, we have reading features, we have reading reference features, we have reading objects in different bookmarks that are easy to copy and multiply, depending on the AIXM feature type that we are producing. And on the right, we have managing the data, mapping it, and sending it to the writer. So yeah, this is what we did. And you can see we also have some linked custom transformers, so that if we needed to change something, that would get implemented automatically using the linked custom transformers. Yep. Okay. So that was the actual one of the AIXM producing workspaces, and then we had the master workspace. I'm just going to run through this very quickly, but as you can see, we were very strict with working with bookmarks, making sure that they are noted properly and everything. So we pick up parameters and figure out what kind of a job it is that we want to do. And then we start running the exports with a job submitter almost in the middle there, and then receiving the results for later use. You see that custom transformer in the middle, that green one. That one is quite important for what we're going to talk about soon, so we'll get back to that. We also had to look for error messages because depending on what kind of errors that the actual exports through, we needed to either ignore them, handle them in some way, and retry the export. We had some, initially we had some problems with the WFS server sometimes not responding. And then we could catch that error and try the job again. And luckily for us, they never faulted twice in a row.
Yeah, quick note there,
Yep.
Johan. I think this is a fairly common setup when we build solutions with the FME Flow, that you have like a master workspace that receives different job requests and then it directs and runs subjobs. But I think it could be an option to use the automation framework more here, possibly. I don't know what you think, but it could be possible, I think.
Could be, and that is, I'll get back to that actually in the end of the presentation. So thanks for.
Yeah, that's a good point, Ulf. Yeah. In general, the whole parent-child workspace thing, there's probably some advantages to each approach.
Yeah, it can be a
bit more granular control.
Yeah.
Sorry, go ahead.
Yep. Okay. Then we also have a part where we use that we have to determine if we should do business rules validation, Eurocontrol EAD business rules validation. I guess some of you are familiar with the concept, and I promise you we will get back to that very soon. And then we just end up packaging everything and sending it to the zip file that the trust application has named, and telling it that, yeah, we're done, you can pick it up. Okay, so I mentioned validating data. What is a valid AIXM? Well, the first thing we know is that it is important that we do the schema validation of the AIXM. That is an integrated part in the FME AIXM writer. It has AIXM has an XSD schema that you can check the write. You can tell the writer to either validate the output on or just ignore. And of course, it's important for Swedavia that they are valid. We had some project-specific issues for handling permdeltas because the database didn't have any fields for nil reason, which is something important when you handle permdeltas in AIXM. So we needed a lot of null replacement values for that, which broke the schema validation. And also we had some problems with numeric formats from the WFS, which also broke the schema validation. Then we have to adhere to GML for aviation. It's a subset of the GML standard for the EAD, for AIXM and EAD, and we couldn't quite get the standard AIXM writer to follow that. I don't know if that was an issue because we ran FME 2023, not 24-25. But anyway, that was a problem for us. And then we also had to adhere to the business rules. And like I said, we will come back to that. So how do we, the first two problems, the schema validation and GML for aviation. Well, the simple solution was actually to ignore it in the AIXM writer, in the AIXM workspaces, and do this in post-production. And that was the green custom transformers in the master workspace that I mentioned earlier. And this is a function that I actually love quite a bit. String search and string replace with regular expressions. A thumbs up if you like that.
Now your Johan is better than AI on regular expressions. That's what I learned. I got to you before ChatGPT.
It's a special talent, I'm sure.
Yeah.
Yep. So anyway, we since we knew where we would find these null replacements, and we noted when we looked through the GML for aviation standard, we noticed that it wasn't very difficult to use string replacement to make slight changes, and we would be compliant with that. So that was quite an easy way. So what we actually do, we have a feature reader reading the AIXM as a text file, and then we just process it with string replacers, and it's excellent. Then we have the EAD business rules, a set of complex rules not covered by the XML schema. For instance, a rule that says, if this property has this value, then this object class must exist, or this object class may not exist, or something like that. And you can't cover that in an ordinary XML schema. So they gave us this Excel sheet with over 2,000 rules, and we're starting to regret our life choices.
Yeah, I was just going to say, Johan, that almost seems to me that someone's being paid by the rule. And maybe they're even using FME to auto-generate them. That's
could possibly be that, because what we discovered was that this Excel sheet, this Excel document, was probably more for kind of browsing and viewing, but not actually for working with. So we found that the rules were actually defined in an XML file. And when we browse through, yes, I heard a J. We like XML, don't we? Yeah, we do. So we noticed that most of these rules were parameterized instances of logic tests and as templates, and you can see that in the image as well. And they were also categorized very well. So by starting to filter templates and rules, in the end, we only had to implement 42 templates and 31 individual rules instead of 2,000 something rules from the Excel file. So when we decided on, when we noticed that, we went about it similarly to our AIXM workspace job. We created easy to copy bookmarks with some custom transformers. So this, we created actually 3 of them based on different types of rules and rule sets. But it was very easy because for each template, this is a template bookmark. So for each template that we needed to implement. We just took this bookmark, we copied it, and then we only had to change the yellow extract test parameters and the light green configure BR test and the purple error report. And then we were set with that template and can go on working with the next one. Of course, it took some time to create the bookmarks. We had to implement 4 or 5 of them first to get a hang of it and realize what was easy to copy and what was not. I guess someone being very good at Python could use the Python caller for a lot of this and actually do this in one custom transformers. But none of us working in the project were quite comfortable with the Python caller. So
yeah, this is a common trade-off, I think, in more complex projects where you kind of switch between, you know, okay, we want to do something small and efficient. It could be code, but then maintaining it in the long run can be much more complicated. Here you have a visual representation of it that probably quite a few people could understand.
Yeah.
Somebody, sorry to interrupt, Johan. Somebody asked a good question about were either the Excel or I guess the XML is more machine readable in a sense than the Excel because of the structure. But were you able to could you build some of the tests automatically based on those rules? Or sorry, based on the XML, or you're basically pulling out some of the test parameters, but then you still have to use things like tester expressions in FME. It's not like there's an actual rule type defined in the XML that you could just execute directly.
I guess I'm not sure if you see my pointer, but if you look at this, you have the tag SBVR, which describes the template test in kind of a semi-code manner. I guess
like pseudocode almost.
Like a pseudocode, yeah. I guess if you could work that out and thus not needing our configure BR test bookmark here.
But that would be kind of an extra layer of abstraction that might be a bit more work to set up. But yeah, interesting idea. Okay.
Yeah, definitely.
Would be interesting to try some AI to see if you could figure that out there.
Yeah.
Anyway, so that was the talkative part of the presentation, and then let's actually do some validating of some AIXM files. Ulf?
Oh yeah. So here, this is where produced AIXM file is being validated by these business rules. And, you know, it's sort of a spoiler alert here before it even starts this demo here that nothing will be produced because everything is correct.
Yeah.
Right, Johan. So here you have, you actually have the different business rules there.
Yeah, those are we have an attribute filter on the templates to minimize sending duplicates of the templates around the workspace.
Yeah.
And here you see we have the bookmarks, one bookmark for each template. Like I said, it looks daunting, but it's not as bad.
Yeah, but as we said, the result here is like nothing output because Johan always creates perfect AIXM, correct?
No. Actually, after 6 months of working with this, it's Swedavia that learned how to create the proper AIXM database data for proper AIXM creation.
But anyway, to get some results out of this, in the next one, we tried to run it on this sample data we showed before, just to get some exciting outputs.
Did you break something, Ulf, just to make things interesting?
No, we did not actually break that. We instead of using Swedavia data, we take this sample data we showed in the beginning to try the business rules on those.
Yeah, actually, you make a good point there, because if anybody's new to AIXM, a lot of the published sample data sets that are sort of meant to be educational are full of errors. So
Yeah.
It doesn't exactly help people who are starting out in this.
So let's see if we can run it. So we turn off this. We have this check for checking backwards compatibility in here.
Yeah. We won't talk about AIXM 4.5, I guess.
No, but if we had that left in there, we would get like 300 or 400 messages.
Oh, okay.
So, but now we turned it off. So, and I think it is things like where you don't have the units and stuff like that in there that comes out in this sample data file here.
Yeah. Missing units of measures or missing references. And
yeah, the kinds of checks that are in business rules, I would say. The AIXM format in itself would allow for quite a few variants and combinations. This is where we run it with the backwards compatibility check. Yeah. So we would have like quite a few warnings here that this would not be backwards mappable.
Yeah.
So does Swedavia have access to running this validation themselves, or you send them the log and then they go and fix it? What's kind of the workflow there when you're identifying problems?
This is one of the rule jobs that the master workspace starts after it has run all the individual AIXM exports. So based on what kind of temporality, it's not all business rules are interesting to test on all temporalities. You don't test referential integrity for delta sets.
Right. Yeah, I was going to ask that earlier. If I guess you're using, AIXM has two modes, snapshot and update, and most of what you're generating are the update types.
Yeah. Well, the workspace can generate baseline, snapshot, permdelta, or temp-delta, whatever they want. But the most important for the actual use case is the permdelta export.
Right.
Yep.
And regarding this, I mean, it was quite a raw log file output here, but it would be fairly easy to make a nice report out of that within FME Flow, so you could have some, graphs and numbers of different types of errors and so on. But
you could do things like HTML report generator, and then you can also maybe and one option might be to only report unique errors. Sometimes you have the same error repeating 1,000 times.
So you can get some stats.
That would be relatively easy to do.
Yep. Okay, moving on. So what's next? Well, Swedavia will have to implement the PC and PCR shift in AIXM 5.1. I guess some of you listening are familiar with that problem. And then we have a lot of enhanced performance jobs. And there we come to, should we still use master workspace and child and job submitting, or should we start using automations of some kind? Should we continue to read data from the WFS, or should we push on that we actually want to read from the database? That's the one I'm lobbying for. And then sometime later, going over to AIXM 5.2. Not sure when, but it's on the horizon somewhere. So what were the benefits? Well, saving time and saving money, to be quite frank. The main benefits of doing this for Swedavia, using FME and creating these. And also having their own control of the process was also a benefit. Yep, that's it. Thank you all.
Excellent.
Fantastic. Awesome. Well, thank you so much, Johan and Alf, for taking the time to show us through that use case. Super insightful. We do have Alf and Johan's emails on the screen here in case you have any questions for them after the webinar. But of course, once again, we encourage you, if you have any questions from today's use case, please use that questions tab. And we're hoping to have a few minutes at the end here to answer some live. Okay, so with that, I'll pass things back over to Dean for our next section here.
Very good. Well, yeah, again, thanks, Johan and Ulf. That was a very in-depth, comprehensive workflow for providing perm deltas and for Swedavia. So that was, yeah, very interesting use case. So we're going to dive into just a quick update. So what Johan was talking about there was all about generating or writing the AIXM perm delta updates. But what I'm going to talk now about is more about the reader, the new AIXM 5X reader. And a little bit of background on this. There was a really good presentation that Matthew from the Dutch Air Traffic Control, LVNL. He gave a presentation in the Peak in Bonn back a couple of years ago. And it identified some challenges with linking airspaces with linked geometry to geoborders. And so really, there was a number of other issues identified with the reader where we were either missing something or basically reading things in a way that required a bit of kind of the post-processing that Johan talked about on the writer. And so we decided, just to make life a bit easier for our users, we were going to make a new profile of the AIXM5 reader. This specific case is focusing on the linked geometry. So as I mentioned earlier, an airspace object has airspace time slices, but even within the time slice that holds the geometry, some of the edges can have links to other feature types. And in this case, you can have a link to a geoborder, which is like an international border. And so the airspace definition, for legal reasons, is actually pointing to one object that defines the border, and that avoids duplication. So there's all sorts of regulatory and legal reasons for that. The problem is it actually goes beyond the GML spec. It is, GML does not actually have a concept of there's concepts of linked geometry in GML, but not the part where take this long feature and clip it by the boundary where it intersects the airspace. So that kind of complexity is something that we had to build a new reader for that, which is a wrapper around our GML core. And so now we can handle, not just for airspaces, but for any of the AIXM objects that have linked geometry, we can handle some of those complex linked geometry use cases, as well as a few other enhancements I'll mention in a sec. So as I mentioned, Matthew Bracking, he gave that presentation, but then he was generous enough to work with us on kind of addressing a bunch of the issues that he raised. And so we kind of had this interactive development effort where we had sample data from him and made sure that we could parse that and interpret it more accurately. And yeah, so again, it's reading data from the EAIP database and EAD and converting that to GIS. So that's kind of the main workflow that we're trying to support. And yeah, just to mention that LVNL has been from time to time a customer of Sweco as well. So this is what the new reader looks like. And this is new in 2025.0. There might be one or two minor bug fixes in .1, but for the demos today, we use .0. And it'll run fine on that. Like I said, it's a wrapper on the GML core, so it's still using. So we have a GML core in FME that can basically read and write data by any well-formed application schema. It's very powerful. It can do things like GeoSciML, even though it's not on the formats list. So the new reader is built on that same core, but then there's special handling for things like these linked geometries. And then, the workarounds in the past required there's an option on the reader where you can attach an XML fragment of the entire feature and parse that and handle things that the reader might have missed. So that kind of post-processing is no longer required. And so on the bottom right, we have some of the new settings in the 5X reader for things like geodetic arcs to interpret those. So that's one of the main differences between the two, looking at those. And this is just what a link geometry looks like. Not expecting you to read through all the XML. You can refer to the deck later. But the idea there is that on the bottom left, there's an Xlink href for the GML ID. So as one of the curves in the airspace, it points to that ID over in geo borders on the top right. So that geo border edge gets included in the airspace. So this is what the old reader looked like. And you can see it doesn't follow the border particularly well. And this is what the new reader generates. And we have a quick video where we kind of zoom into that. We can run that. And so, again, I'm focusing on airspaces, but this will, this kind of same functionality exists for a number of different feature types wherever link geometry is used. So in this video, the first one, I just point out there are different ways of reading the AIXM version. So you can actually, I'm using 5.1.1. There's also 5.1, or just directly interpret it from the data set. And this is the old reader. And so if we zoom in at the border there between Belgium and France, you can see there's an airspace. Let's see what the name of that is. This low, Koski low sector. And you can tell by the GML ID when we read it again with the new one, that in fact it's the same feature but being more fully interpreted. So yeah, we're going to choose the 5X reader, and so that's probably the one we're going to use going forward. I mean, we'll have backwards compatibility with the old reader for now, for at least a version or two of FME, but eventually the 5.1 reader might go away. And so this is reading in with the new reader, and again, if we zoom in, you can see that it follows that geo border. And it sounds like a simple thing, but I think it saved about 50 plus transformers in one of Matthew's workspaces not to have to look for that edge that's missing and then, have a bunch of transformers to find that edge in geo borders and then link it into the airspace geometries. That's a lot of work to do for the user. And, if you don't do it quite right, it could be prone to errors as well. So yeah, that's pretty much it. So if I can get back to the deck, and that video will be available in the deck after. I just wanted to mention there's one or two other improvements that we made, adding support for different interpretations of geodesic arcs. And if you have a couple 100-kilometer arc, if the difference between ellipsoidal or spherical can be 1 or 2 kilometers, so it's not a minor thing. And so we've exposed a bunch of parameters here. Maybe at some point we might add presets, but we decided to kind of expose those dials so the user can use them. So just a quick summary before we go to Q&A. So the new 5X reader, basically there's a bunch of bug fixes in there. There's full support for the Xlink geometries. Airspaces can now handle those linked geoborders. Geodesic lines are supported. And then there's just a side note, as I had a recent support case about this, there is an application schema entry. So if you have a profile like FAA, you can just link that in on the reader. So ultimately, just our goal is to make it simpler to work with this complex data structure. So just to wrap up, AIXM supports the collection, verification, distribution, and transformation of digital and aeronautical data. And I guess I would add to that the exchange of data, because that's what has to happen between the data authors and the regulatory agencies. AIS information systems are getting increasingly complex with the volume of air traffic and the different types of subsystems involved with things like UAVs that are coming along. And the new FME 5X reader addressed some known reader issues and vastly simplifies the interpretation rendering of those. And just a great demo by Sweco, Ulf, and Johanna about Swedavia and how they've built their services, update services, using the FME platform to provide permdeltas of their AIS data. Yeah, so just to wrap up, just a footnote about standards are an important thing for FME. So there's a few standards there on the left. And we continue to grow and have a presence around the world. And there's a number of resources I did give a more detailed talk on the reader at the peak, and so that will be available for download. And there's
Yeah.
lots of other customer stories there.
Just to chime in here at the risk of not sending out, 12 different links in the chat here, you can always download the deck just as a reminder and navigate through these links, including that peak deck that Dean mentioned.
Yeah. And there are some resources there. We have a few articles on the knowledge base about AIXM and just using our academy and past webinars. And yeah, feel free to contact us. I'll put my email in the chat in a second once we get to the Q&A. And then there's the accelerator. Highly recommend that if you're new to FME. And I guess that's the badge code. Elizabeth?
Yeah. So I'll drop that in the chat now if you're a member of our community and you like to redeem badge codes as a thank you for joining us. So you can see the code on the screen here or just copy it from the chat. And if you aren't a member of the community, I think Dean and I can both speak to how great of a resource the community is, lots of forums there, and you can network with other users and experts alike.
All right.
Okay, so I'll invite our presenters if they want to turn on their webcams and we can come back on stage here to wrap up. It looks like we were able to get to all questions in the questions tab so far anyway. We've still got a few minutes here, so if you have a question, please do drop that in.
I have a question for Johan. You mentioned AIXM 5.2. That seems to have had a kind of a rolling deadline. You don't have a current sense of when that might come out or be released?
No, I don't. But no, I don't have a deadline. But it's a topic that is brought up in the discussions between Swedavia and Luftfartsverket.
All right. Well, Matthew is, again, thanks to Matthew for your contributions. He's online in the chat. He mentioned that 5.2 is already out. So there we go. So I guess there's the release of the standard is one thing, but adoption by Eurocontrol and FAA would be something else. So that's something I guess the different agencies will have their own timeline for. And we can certainly I'll put that in the pipeline on our development side to make sure we support that, when we have a critical mass. The other thing, as I dropped my email out there, I just remembered I was planning to ask people, if you do want to be on a specific email list associated with the development of AIXM or updates, like sort of more on a technical level, feel free to drop me an email directly and I'll add you to a list. And just say, hey, I want to be involved with, let's say, technical updates on the reader or the writer. And, yeah, I'll try to keep you guys in the loop.
You probably have Johan and me on that list, Dean.
Yeah, okay, I'll put you guys at the top.
Yeah.
And Matthew as well. Were there any questions we didn't? You said, Elizabeth, we covered most of them.
Yeah, it looks like we've gotten to all of them. And I think we answered one or two live during the webinar too. So unless any of you as our presenters see one you want to highlight or elaborate on, feel free to take a look through there.
Yeah, what was there was a question about WFS.
Yeah, and it was one of the early in the project. The WFS server was set up prior to us joining the project, and so it didn't take many months before we questioned that decision, but they decided to stick with it.
So it was already part of the infrastructure, and you just have.
Yeah, it was already part of the infrastructure.
Yeah.
At least we could say it was OGC compliant.
Yeah, for sure. Although there are new OGC APIs, which might be easier to work with. But yeah, I mean, you mentioned that it was intermittent, and that's another case where if you're using Flow, you could check, oh, is it up or not? And then maybe generate a warning or just get it to try again later. So you can kind of automate that if you had an intermittent data source like that.
Yeah.
I did want to circle back really quick. There was this question between automations versus a parent workspace for running stuff. Do you guys have sort of an impression as to what is better, or what's the pros and cons of each approach? Maybe we'll wrap up with that.
Yeah, I could say I think when we started looking at automation, not for this project, when automation was introduced, and I think one of the major things that kind of made a few people hesitate a bit was the logging capabilities to keep track of that. But now there is almost too much logging in it, I would say. Well, I think it could be feasible, but then of course there are some granular things that benefits if you are in a actual FME workflow.
Yeah,
so,
if you're in a parent, because you have feature level control over what's going on.
But I'm quite sure, but you can correct me, Johan, but I'm quite sure you could break out a few things from that master workspace and have that in an automation, because I mean, I mean, the possibility to rearrange some of the logic and be able to do that in FME Flow is quite useful in many cases. You know, if you have modular workspaces that you can rearrange in the automations through the FME Flow user interface, it can benefit you a lot.
Yeah, I would think going forward for managing, it's just a different type of architecture, but if for managing modules, you kind of design your workspaces differently for automations versus for, you know, sort of the older way. Yeah.
And as I said, the logging is there now because it's very nice to have these FME workspaces and the job IDs and the log database to keep track of it. But there is extensive logging in automation now.
Yeah. Well, we should probably wrap up, I guess, Elizabeth. But
yes.
Personally, I wanted to thank Johan and Ulf so much for enlightening us as to this actual, you know, real world use case, how this is being used every day, and keeping our airspaces and airports safe. So, you know, kudos to you guys for that implementation story. And I wanted to thank our audience for being with us today and you know, asking some good questions, and, you know, just tracking how, you know, FME is used in this case. And and
thank you to Dean as well for taking the time to share this content with us as well. We appreciate it.
Well, thanks for having us.
Yeah, thanks for having us.
Our pleasure. Okay, well, hope you all have a great rest of your day. I will leave things running a couple minutes longer. Feel free to add any questions if you have them come up, but otherwise, feel free to reach out to any of our 3 presenters as well. Awesome. Thanks, everyone.
Yeah, happy to follow up.
Yeah, absolutely.
Absolutely. Will.
Okay. Right. Bye-bye.
Bye.
Bye.